Welcome, everyone. So it's a 2-hour tutorial. We have 2 tasks to complete for today's session. The first task is about understanding email authentication, and the other task is understanding PCAP files on Wireshark. Yeah. So we'll talk about that after this. So we talk about email authentication in some way or the other. We were talking about spear phishing emails, spamming, and other things. And one other question: how, when attackers spoof an email, what are the solutions that we have? One of the solutions is email authentication. Right. So I created this document, and I'm expecting you to go through this. There's a really nice information, very concise information about it. Go through this, understand what is SPF, what is DKIM, what is DMARC, why we use it, up to what extent we can control spamming, spoofing, and what are the still ongoing issues that we see. Yeah, so first we build the concept in terms of understanding them, and then we will look at some, so then we will look at your own email inbox to understand how to fetch this information within your email header. Yeah. So every email has a header and body, and generally this kind of information is within the header. This will help understand it, whether this message seems to be spam, seems to be legitimate. Because now, I mean, earlier it used to be quite easy in terms of understanding spam, but then now you see these emails are more customized in nature. So they kind of pick the exactly same information. It becomes much harder for you to understand if this is spam or phishing or not. But we will do some exercise related to this. So we'll spend few minutes, spend around 20 minutes or so, go through this task 1, whatever document says, and try understand what these 3 things are. We'll discuss them, and then we'll do some exercise. And each of these are become kind of a standard. So you see they have the email address where you can go and see what kind of development they are doing. So each of these are having their own RFC, request for comments. Yeah, so whenever you kind of have a standard, whenever you want to make any changes to it, there's always a proposal that we call request to comment. And there are working group of people from academia, industry, and so on. They're working together, try resolving those issues, thinking about what should be part of the standard, and so on. Okay, so let's go each of these, try and understand what this document says, and then we'll have a discussion over it. Okay, so when you read this SPF, it's something. It says something about DNS. What is DNS? Why we use it? Okay. What else? Yeah. So DNS is a domain name system or domain name server. When so earlier when we had this concept of IP address, you have to assign IP address to a machine, and then whenever you need to contact to that machine, you need to get that IP address to connect it. When the system was small enough, it's okay. Possibly you can have a list of IP address and you can map it with the device and so on. But then now we are talking about so many devices, where it's a very large number of devices we are talking about. So it's very hard to remember, keep a track on those addresses. Yeah, that's why people come up with the name of domain name, right? And that creates kind of a mapping for you. So you need to remember the address of the website in terms of text, which is easier to remember or compared to IP address. So there's always a mapping somewhere that's help you do that. So whenever you say www.google.com, what happens? Your request is sent to the DNS. DNS for this particular text or address, what is the email? Sorry, what is the IP? Now, when we say IP, I'm talking about public IP address of that particular organization. Yeah, so it picks the IP address, put as a destination address, connect to that server. Now, sometimes that server doesn't have answer to that. Yeah. So let's say if I'm fetching information from here from a server in the US. So it will first connect to the server in India. If that server doesn't have the answer, it will connect to other. So sometimes, so kind of how you decide which server it has to connect is all done by DNS. Kind of. So DNS will look up saying what are the other servers of this organization and then try connect. So what is our understanding? What is SPF? Yeah, so but let's pick example where you receive a message, okay, from some domain. Let's say that we don't understand, that's not popular. How would you get a sense that, and of course email, these days they have this kind of feature, automatically categorize it, whether it's a spam or not, and so on. Let's say if you don't have any filter, you just receive a message. How will you get a sense that this message is coming from a right source? What would be those things you will look into to understand that this email is coming from the authentic source? It's not spam or it is a spam, whatever. How you decide on? What is the very first thing you do? So what would be those things? We'll look into this, but I just wanted to know first the concept. Because once you, if you are able to understand the concept, then only you will be able to see connected. So the first thing is, what is the role of SPF? What is the full form? What it stands for? So it's a sender policy framework. So it's a framework that presents some kind of policies for senders. It should reflect some information that possibly we can use for verifying the sender in a way, the details of the sender. Yeah. So when you receive an email, if you don't have any filter, what you're going to do, you look, try understand what is the mail server is coming, which company is coming from, or what is the IP address of this server in a way, right? So there's something called, so they always keep a file on their DNS, is called spf.txt, this one, right? So there's always a file, a standard file called spf.txt. This includes all the IP addresses of the external servers of that company. If the company is using one server with particular IP address, the IP address should be inside this file. If you receive a packet from this particular server, you just go to the website. If you see if there's this file, and if there's that particular address, that means whatever you receive is coming from the right source, right? So that's a basic thing to understand. This will helps you if somebody is kind of impersonating things or creating a false fabricated messages with a fake IP address or other IP addresses. Yeah, that might not be easy for us to pick whether it's. So yeah, no, I don't know what's going on. Right. And that's why we have this sender policy framework, which says if you are, this is the practice. If you have any server which is talking to externally, now when we are talking about email, in this case, so we are talking about email server. Yeah, if you have an email server, make sure when you have a domain in your DNS server, you put this spf.txt, where you put that IP address of this particular server, so that people get a sense that whatever there is coming, they can verify whether this IP address matches to your IP address or not. And this will clearly help us understand whether this is spam or not. The other is DKIM. What is DKIM? Domain key identified mail. What does it mean? What does it do? Now, what is the policy? What is the problem with SPF? Now, we say you put your IP address in this file. Problem should have been resolved. What are the issues? One, there could be possibility of DNS poisoning attack, where attacker can compromise, for example, this file, add new addresses, or delete other addresses, for example. Or in standard, not every organization maintaining this file. Yeah, so this file might be empty and you have no idea whether it's authentic or not. So how are you going to verify it? And it's just about the address, not the content. It just says it's coming from this source, but it's not. SPF doesn't say anything about the content, right? Now we have DKIM. DKIM says you have to sign the message before you send it. How do we sign it? Private key, with the private key, right? So as a company, I will use my private key to sign all messages. Sign means simply encrypting, or you applying signature algorithm with my private key, and I'm sending it. And I'm giving this key as well somewhere so that people can access my public key and then verify it. So they get a sense whatever is coming, they can easily authenticate whether who is the source and what's the content. Now when you sign it, what are the properties we maintain when we sign a message? One, source authentication. If you are able to decrypt or a message using a public key of a person, you can easily understand this message was created using the private key of that person. So source authentication is there. Secondly, when you design, when you sign a message, part of message you are also using hash functions, because you are encrypting the hash code, not the message itself. When you create hash code, that means we are also integrity. We are maintaining the integrity, making sure message is not being tampered in between, right? Third, repudiation. So digital signature by default maintain repudiation in the system, so you can't deny it. If you are able to decrypt the message, and if you are showing somebody message, that means you have received it. That's how you were able to decrypt and got it this. Similarly, the other way, if you are able to decrypt it, you can say this message was created by that person. So that's what it says. It allows an organization to claim responsibility for transmitting a message in a way that can be validated by a recipient. Because we also wanted to understand the content, not just the message coming from a source, particular source. So we also wanted to understand whatever content is being, and that's how you get a sense whether it's not spear phishing or so on, right? Especially more spear phishing, because content might be changed if there's no protection in that. Someone can tamper those messages, keeping the same source, but then modify the rest of it. So it says DKIM takes email sender identification by associating a domain name and owner to the content of the email message by cryptographically signing the content using private key. So as we know, we can sign a message using private key. Whoever holds the public key can decrypt it. They say signing the emails, but not by the sender, but the sending mail server. So that could be another problem, which says this message was signed, this message was created by this organization, but it's hard to understand within the organization which person, which system has created it, because it's signing the private key of the server, not the individual system. within the enterprise. Yeah. Private key is made available to the recipient by a special DKIM specific DNS.txt file. Anyone can have access to this file and they can get the public key and kind of get the message. The receiving organization can then use the public key to verify signature, thus giving them a firm determinant as to whether or not the message contained vouched. Signature verification, no one altered the signed property of the message while it was on the path to the recipient. It's also said that DKIM alone is not a good basis for a spam detector. It's easy for a spammer to set up and use DKIM just like anyone else. Now, why detecting spam is difficult? As an attacker, you might have a company, you might also have a server, you might also have a DNS.txt file, SPF.txt file, you have legitimate IP addresses and so on. So if you verify all these things, they all go correct. Yeah, so it looks like it's legitimate, but it's kind of organized crime. So adversary might have all the legitimate things for a server to maintain. A more robust choice allows you to deliver tag deny subject in certain situations. It says when a DKIM signature is present but not valid. When no DKIM signature is present or when a valid DKIM signature is present. Now again, the same problem is not everybody is following this. Sometimes people are creating signatures. The signatures are old, maybe expired, so you can't verify them, or your system doesn't verify them. Because it's the additional task, you need to go to this and get the recipient, go to the public key of the sender and then test, try decrypt, verify signature, and then come to a point. So again, it's an additional work that comes with extra cost, right? So if you, as a company, if you want to take that pain, it's okay, but not everybody wants to do that. So sometimes you see there's no signature, or there are signatures, but they're not invalid, or other issues. And then we are talking about the third thing is called DMARC, which is domain-based message authentication. What it does? How it's different from your DKIM, for example. What it says? It says it's improve SPF and DKIM, yeah, by providing a framework for receiving organization, which I'm finding hard to verify. I'm not really sure whether it's spam or it's coming from you. If you can fix 1, 2, 3, everything will be perfect. So in a way, you are giving a feedback to the sender to fix it. And once they are able to fix, recipient can verify all those things. Yeah, so it's all about giving feedback and improving the whole process so that more and more people can start following this practice. It said DMARC enable domain owners to publish policies that can be considered by recipient when handling SPF DKIM failures. When there's no SPF record, no DKIM, you always give them feedback saying, can you put a file, can you put an IP address of your server, maintain those files, and update those files if things change. Such policies significantly reduce user exposure to fraud and potentially malicious emails. With DMARC, email receivers can report back to the senders critical data about the message that pass or fail DMARC authentication, so the senders can take appropriate steps to improve their sending posture. Now, as I said, the technology limitation is not all companies are following this practice. Some are saying, some are not following, or partially, whatever. Second thing, even if everybody is following this, sometimes it becomes very difficult to understand because attackers can also do the same thing. They can have their own company having server and following all this practice correctly. So they looks like legitimate. It's very difficult for them to understand that they are the malicious one, not the legitimate users. Yeah, so it says while SPF, DKIM, DMARC offer hope to many enterprise, there are some limitations. One of them is because so many organizations SPF records are inaccurate, most are hesitate to block email just because fail. Because most companies don't maintain those, doesn't mean they are malicious. If you're blocking them, you might be blocking malicious, legitimate emails as well. Secondly, its problem becomes more complex in terms of cloud environment, where you have data storing from different companies, right? And if they're putting those kind of record for maybe one company that doesn't want this to reveal, but the other company wants to reveal all this information. They want to maintain it. But the server but that's the same server. It's just the data that is, there in a different format or whatever. But all the data at the same server. If one of the company maintaining this kind of thing, they would like to maintain and reveal this information. Maybe on the other hand, some company might not, but they don't want to. But you end up with revealing those things. So this makes it virtually impossible for SPF to be used to effectively tell difference between the one center and the next to on the same host platform. And sometimes it also happens that servers forward emails and so on. So sometimes that if you try to verify them or validate them, they don't work. So the number of problems, but if we can solve this problem, this could be one of the ways to kind of mitigating spoofing and spear phishing. There are two examples I covered. One is PayPal, one is LinkedIn. There's two companies that are really correctly following this practice. They're maintaining all these three records. And that's why PayPal, people have more trust in PayPal when it comes to transactions, right? And LinkedIn also follow the same thing. Now what we want to do as a part of this exercise, whichever email you prefer, I just give example of email, but you can have your university email or whatever. Open an email from your, for example, Gmail account or university account, and you see, so I'm just giving the example from Gmail, but might be it's a bit different format in your inbox. So if you see these three dot lines, you go to the upper right corner and click show original, so that you can see the header information of an email. Then say pay attention to SPF, DKIM, DMARC, SMTP if you have that, MIME, whatever. So look at some email that you receive. What does it look like? And the second exercise, you can go intentionally in your spam folder if you have in the inbox and try see if you can get those information. Are you able to understand by looking at that this seems to be spam? The emails have that capability now. They can filter it and then putting into different folder. This is a spam, this is not a spam, but we can put our own logic to derive that information, whether this particular email seems to be legitimate or malicious and why. Yeah, but it's still 100%. It's very difficult to 100% classify everything correctly. Let's do this exercise and then we'll talk about the third. So third one is simply say look at the paper. So I gave you a paper as well, research paper. So we are expecting, again, it's a large scale and longitude measurement study on DKIM deployment. So there are a lot of research people do based on what people suggest. So they wanted to know which other company, up to what extent DKIM is in practice. Whether company have deployed. If yes, then how they look like, what are the still issues, what is the % of companies who have deployed DKIM, what are the current challenges, even after deploying, are there still issues, and things like that. So possibly you can look at some tables and figures. I mentioned like table 3, 4, 5, 6. Then figure 9 will give you enough information what's going on in this domain. So if you find an email with all these three things, it can help you to understand, but not necessarily it can correctly classify. So for example, if you're looking at Gmail, Gmail has their own logic to understand things. Obviously, they will look for all these three things. But apart from that, if all these three pass and there are emails that you are not clicking for some reason, it will start putting into spam or some other folders. Yeah, considering that might be not useful for you. That's what I'm saying. What's very, I mean, one example could be there is an attacker, having a company, having a mail server, and maintaining all those three things. Yeah, you'll send any email, you verify this, say all pass. So just looking at these three things, not necessarily the email is a spam or not spam. So this is just one part. One part is header, that's what we are looking for. But then there's a body of email also. Yeah, and the behavior or pattern of the user. One email might be useful for someone, may not be useful for someone, some other purpose. Yeah, when you say malicious, it could be random email as well. Somebody is advertising some healthcare product. Yeah, and then of course they got several emails they're broadcasting kind of. When it hits your system, it's not customized to you, but it's just advertisement kind of email, right? If I'm not interested in a healthcare product, for me it's a spam. Others might be interested. They might start looking, oh, I have this issue, let me see how does it look like. So there's also a way of promoting advertisement channels in a way. So some companies also do that. 50% off if you book in this website, blah, 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 blah. Yeah. Now, so spam could be kind of a broad category where spam can harm you. They may not harm you in a way, right? So you have to, it's all about training, the way you train your model. It's very similar to, you look at the header, this, which is the header part of this, but then what data, what content you are getting, and you train your model about that content. Are these content useful for you? If yes, so for example, in this it asks you, if you go to spam, click on only, it will ask you, do you think spam? If not spam, you can move it to the inbox, right? If you move it to the inbox, the further email that you receive will go to inbox. If you don't click for a time, they all go to spam. For your inbox, it seems to be they're not useful for you. That's why it's not easy. That's if it is as easy, then we don't have spams. Yeah, because you're not clicking. That's why. When you come up with some solution, attackers always go ahead with this. Say, how can I crack this? So say, I can also have the same server with everything installed, everything perfect, and I can still send. I can still crack people. I can still target people. Yeah, so spam is one thing where most of the time the message is not customized, but it's more general. Dear participants, hello, valued customers, blah, blah, blah. If someone knows your name, possibly it's a bit customized, might not be spam. It can still be spam, but generally it comes through advertisement or for business purpose and advertisement. So, but we also look around something called phishing. And phishing can also only be detected when you look at the content. Are there any link in this, and so on. If yes, then does it one of the malicious links? So you connect. That's why it's very difficult to detect phishing. Because in order to do so, you have to maintain a large number of data sets or connect every time whenever you, and then sometimes people don't want their message to be scanned. Yeah. Okay, so this is 1 and 2, and the third one says, so I think I'll also send you a paper. So if you look at the paper and the tables, I can also see if I have. Which is this one? So as I said, this is one of the studies of large scale and longitudinal measurement study on DKIM deployment. People from North China Institute of Computing Technology, Tsinghua University. So if you look at their table with number, which one I said third, table 3, 3, 4, 5, 6. Yeah, so in order to perform this study, they collected large data instances. For example, they look at the Gmail, iCloud, Yahoo, RU. So again, there's some are Chinese providers as well. So sometimes you receive emails from these addresses, 139.com. Yeah. Earlier, when I used to receive this from 139.com, I was considering those spams. But they are Chinese providers, they're not spams. Yeah, AOL, double Q, and so on. So they collected all emails from different servers, coming from different servers, and they look around DKIM. The table 4 talk about SPF, DKIM, DMARC adoption rate among Alexa top 1 million domains. So they found out of 1 million, I guess, yeah. SPF is around 54%. 54 companies have just adopted SPF, 28% DKIM, and only 11% DMARC. So still very low number. One of the reason is there's not enough trust. Even company follow everything, we still see the gaps. That's one of the reason they don't see things. But this could help. This can help up to a certain extent. Then they look for DKIM adoption rate among multiple TLDs. TLD क्या है? I think it's kind of a domain name. Not domain, but exactly what we call it. DNS. So DNS always have a hierarchical label, right? So it's kind of a label, top label, something we call it. So like .com, .in, and things like that, yeah? So if it is a commercial .com, organization .org, .net, .in, .edu, if it is universities. Mostly in the US, you see most of the universities have .edu and so on. So that top level domain. So they also look into the domain, saying this kind of domain, what their adoption rate in terms of DKIM. So they find out like .com is around 38%, .org is around 40%, 41%, .net is around 30%, .info is around 26%, .co is around 40%, .edu is around 71%, which is much higher, because those are the mostly the education institutes, those understand the value of this. And .biz, businesses, 27%, and .gov is around 53%. Yeah, for businesses and educational institutes, is reasonably good compared to other domains. And then in 6.1 you have DKIM adoption rate among multiple top level domains. So they look into country wise, more specifically .ru, .in. They didn't do .in, but so this could be one of the projects where people wanted to look at .in. You know, what is the DKIM adoption in .in India? So you can do this kind of similar work. So they look into Russia. Russian is around 34%. Germany is 22%, 23%. Japan is around 14%. UK is around 45%. Brazil is around 48%. France is around 37%. Australia is around 58%. And China is around 7-8%. In India, I have no doubt, no idea, but I'm thinking it won't be too much. It would be kind of lower side because not many people do this in India as well. But this is just my guess. I'm not sure. So this could be one of the project if you like to expand on this in terms of what is happening in India particularly. And we said what else? One figure, yeah, which is figure what? Figure 9. Sorry. Figure 9, it says number of percent of different DKIM keys length from 2015-2022. Percent is calculated by log 2 number in different DKIM keys key length. So as we said, DKIM is kind of signatures, right? Now signature means which algorithm you are using, what is the key size, and those things comes into the picture. So they also look into what is the size of key, is it kind of meeting the requirement as of now. So the lighter the length, the lighter color seems lower length, and then the brighter colors says high, large key size. So these ones like 2048, which is the current standard if you're using asymmetric public key, 2048 bit size for the key. But then they are between 1024 and 2048, less than 1024, or between 512, 1024, and less than 500, 512. And then they derive how this has been changed over the years. Yeah, so you see this number is 2015 it was much higher, where people were following the standard, but maybe because of growing new companies, new domains, new sites, new servers, the number got drastically changed in 2016, and then we still have lower than what we had in 2015 in terms of companies utilizing 2048 bit size. Yeah. So all those number below this brightest blue are the weak keys. If anybody is doing with this one, it's easy to crack. Not easy, but relatively easy to crack signatures. Create 4 signatures and start believing it can pass through. Yeah, and you can provide the key and so on, so it looks like legitimate. So similarly, people can do similar kind of research around SPF, research around DMARC, and so on, and give us some understanding. So this is one of the, so this paper is published in, is it in Usenix, I guess? I think so. So Usenix is one of the key security conference around the world, and they do publish this kind of study, where people are collecting very large data and then performing some study to reflect how things have evolved over the years in practice. Right, so let's say there are 100,000 organizations using RSA, so they will look into what sort of implementation look like in terms of RSA, what size of key they are using, and so on. So this gives us understanding whether the practical implementation point of view, where we are we still practicing what we are saying, or actually not the picture. Right, so let's have some 10 minutes break. We'll come back and do Wireshark, yes, one exercise on this. If you don't have Wireshark, make sure you download it now. It's a free open source software. Right, so let's have 10 minutes break and we'll come back. All right, welcome back. So the second part of the exercise, just to know this is a typo, yeah? Just one times dot pcap, it's not two twice. It's a typo. In this exercise, what we're going to do is we will look at pcap file. Pcap stands for packet capturing, right? So Wireshark is one of the software. Through that, you can collect packets and analyze them to understand whether what protocol they are supporting. In a way, you can understand what sort of applications are running within this university. For example, if I can connect to this Wi-Fi, I can collect all the data that comes from this. I can get to see what are the different applications people are running on their laptop and so on, right? I mean, what's supporting different type of protocols. And you can also detect if some of the packets are malicious and so on and so forth. So you will be also able to see this exercise 1.zip file. Yeah? Okay. So what we're going to do before we do on Wireshark, we'll do something online. So you unzip it, and the first part say visit packets.com, which is the online pcap file analyzer. So we will upload this file, the one you got, and observe your outcome. Yeah? In order to do so, you have to click view report. There's some option will come up, it says view report, and then we'll try answer these questions based on what are the different things you see. Okay, let's do the first part first, and then once we are done with this, we'll move to the second part of this. Just double check whether this website is working now. It's apackets.com. Is it working? Okay, good. So you can unzip this file and then upload it to this website to analyze. So the questions that we have say how many credentials were found. So of course, when we say don't connect to a public Wi-Fi, what does it mean? If someone has Wireshark-like device and they are capturing packets, so by default it is unethical for our consideration. If you don't have permission to do so, please don't collect any data. That's why we have this file for you. But ideally, if you have permission, you can collect data from Wireshark itself. So pretending somebody is connecting to the open Wi-Fi and they are running Wireshark to collect all the data. And on this open Wi-Fi, you are using your payment system, passing your personal information, financial information, passwords, whatever. So people might collect them through those packets. They have a tool to analyze them. They can extract that information. You can hack your account. So that's one of the learning. Never use. First of all, don't connect to the public Wi-Fi. If you are doing so, don't use sensitive. Don't put your password. Don't use banking, any transactions, and so on using public Wi-Fi. You have to have your own private Wi-Fi in order to do so, or you turn on your mobile data to use it. Yeah, mobile data is secure. So that is the first one. Second one, it says how many DNS queries were there. So how many packets you got which are having DNS protocol using this, and then out of this, how many are request, response, and so on. When you submit your kind of file to this website, you get all the answers immediately, and then you get to see the detail. Were there any HTTP communication? But now keep in mind that this website there are people who have created this, so whatever you are submitting to them, they have access to this file. So this is good for doing lab exercise like this, but ideally you don't want to upload any personal information, any packets or university packets on their websites. So this is just for us to kind of get a sense what they look like. Were there any HTTP communications? Is there any information regarding RARP packet? What it does? So what is ARP? Okay, why do we use it? physical to IP, yeah? Yes. No, IP to physical. I think so. IP to physical, logic to physical, yeah, IP to Mac. And the other way, RARP is a reverse ARP, yeah? If you know, yeah. Are there any open ports that you could observe? So again, it will also show when they collect data, were there ports that were open part of? Were there any image with HTTP data? So when you collect packet, you can also see how many requests were collecting some kind of image as a part of response, what were those images, and so on. So by looking at the packet, was there any FTP, file transfer protocol, or telnet? What is telnet? Why we use it? Generally, we use it for kind of remote login. Yeah, telnet. Are there any detected servers? Were there any, what? Ethernet. Devices detected, and then there's a kind of network map and so we can look into this. So the whole point is if we are able to collect any data, there are a lot of information you can derive out of it. And you can understand what's going on in this environment. Right? Are you able to upload this? And when you upload, do you see, are you able to answer these questions? What does it say? So you can see all these answers, yeah? So this packet already captured, this file already captured packets, but you can capture your own packets, not here. If you go home, if you have your own Wi-Fi, you can connect to that and you start capturing. So when you open your Wireshark, you see there's a button that will say capture packets. You need to reflect it which interface you are connecting to. So maybe it could be Ethernet connection, it could be Wi-Fi connection, and so on. Once you let it know which interface it has to collect packet, it can start capturing packet. Whatever if you are doing with your laptop, it will capture all the packets. And you can verify what you were doing there. What protocol, did you run any HTTP, whether you're running some applications or fetching data. Yeah. So you unzip this. The very first task is, so there's an online analyzer. We'll do with the Wireshark later on. But the first part, you go to this website, upload the file, and you'll see some response. So we need to check if we are able to answer these questions with that report. Yeah. The second part is about Wireshark. We'll do that with Wireshark. Sorry, what?
Like for HTTP, how we will able to do that in Wireshark?
We'll do that. We'll come to part 2. We'll first do part 1 and then we'll talk about that. Is it working? Yeah, so you are able to see all these things. See if you can answer those questions. The answers are all here.
Number of initials are 0.
Okay.
Queries are 1.
So just click on this if you can, if it gives you more detail what's this about, what is, so it says DNS query. So you note it down somewhere, because when we do the other exercise with Wireshark, you can cross check whether what you found is actually correct or not, and how and why. Yeah, so when you say open view report, you get immediately all the answers there, which we believe are correct. We're not sure, but yeah, but then you can go through Wireshark to double check in a way. But this could be a good tool for you to save your time, if we believe. Not this one, because this is a public platform where you don't want to give your data, but you can buy any product. If there's any tool that you can buy, deploy at your organization, and quickly get to see all those things rather than going through individual packet. That will take a lot of time. But these kind of tools will really say, are there any files, are there any packets having credentials? So it can really make the difference, save a lot of time. Right, so once you upload this file, it will ask you, say, view report. You click on this, get a report, look at the report, get some notes. When it says the number is 0, 1, 2, what are those number 1 and 2? What it has found? What are those queries, responses, kind of, so that when you do this from Wireshark, you can double check all those things. Right, or you can do the same time. So in part 2, what we're going to do is we expect you to open Wireshark. So you go to File menu, open that file, and look at. So this file doesn't have any malware in it, because this is the first file. So it says you should see 26 packets listed. The set of packets describe conversation between a user client and a central server. This entire conversation happens automatically after a user types something and hits enter. Right, so it's like you are Googling something and you search it, and then something happens. It collects a lot of packets, and then it's about understanding what's happened, looking at the packets. Look at the packets to answer the following questions in relation to these conversations. In answering the following questions, use brief descriptions. For example, in frame X, the client requested a web page. In frame Y, the server delivers the content of the page. So there are a number of questions that we need to answer when you look at the packets. And the very first is, what is the IP address of the client that initiate the conversation? Now, even without looking at packets, it says you are searching something, you are typing something, and you hit enter. When you do so, which kind of protocol will enable? What will happen, the very first thing? What will be the first packet that will flow in this network? When you search it, any query, you receive content over the network using HTTP. Right? So you are requesting, first of all. You're requesting for content. You want to search an IT Hamirpur, for example. You go to google.com, you put it this, enter it. Right? As soon as you hit it, what will happen? HTTP request is being created. Right? And we have, so it's about two kind of methods. One is called post method. One is called get method. Post means when you are sending anything. Get means when you are collecting data simply. So by looking at HTTP packets, if you can filter it out, you can get to see which is the first address of, what is the IP address of the client that initiates it. So what is the IP address of the sender in a way. So what is the answer of first question?
Source
Which one?
address. This one, 131.247.95.216.
Okay, if I put it HTTP here in this filter,
Yeah, we can put and then we can filter it from here.
put HTTP, what happened?
It will give only the HTTP requests will filter out. Like if we,
Does it also support if I say
Yeah, yeah, we
HTTP request?
it supports HTTP.
Can I do-
HTTP2 also. Not HTTP request, HTTP2.
For what? For what?
I think so it's for 5G calls. I don't know. I have this for 5G.
Okay. All right, so if you're not sure, you can filter it with HTTP, all the traffic. So on the bar, you see there's a filter bar where you can put HTTP, hit it. You see all the packets that were delivered that were used HTTP protocol. And the first, whatever the first protocol, the sender is the IP address. The second question, it says, use the first two packets to identify the server that is going to be contacted, list their common name, sometimes we call this CNAME, and 3 IP addresses that can be used for the server. So what happened when you hit it? Of course, you create a HTTP request is being sent. Now, where will request go? What will happen? If you're using Google server, it will try connect to the Google, right? And before that, how it will do? It will go for first of all, DNS. Because you just put maybe google.com. It doesn't know what is google.com. It will look for IP address. Where? DNS. Right? So it will run through DNS protocol, get to see CNAME and what are the IP addresses of the server. There could be one, there could be more than one IP addresses. Yeah? So maybe if you are filter it with DNS also, or maybe if you don't filter, it's just a first 2 packets. If you look at the 1 or 2 packets, within the text body you should be able to see CNAME of the server as well as 3 IP address. Are you able to do so or not? Okay. How about you guys? Is it working? So you don't filter it. Delete all filters. Yeah, don't filter it. There's no need to filter it. But just the first 2 packets. So you look for second packet. 1 or 2. If you click it, yeah, just double click it. I mean, you can okay. Sorry. So you can read it from here as directly if you see. This is the CNAME. You see this? And this is the first IP. That's the second IP. And that's the third IP. Or you can double click it to get more detail. It should be, so again, you can look at layer 2. What is MAC address and so on. You can look at IP addresses, source IP, destination IP, which protocol, XYZ. And this is your transport layer, this is your DNS, yeah? Yes. Click on this. You can see it here. Do you see this?
Yes, sir.
That's the CNAME. And these are 3. This is kind of hexadecimal equivalent to this. This is the address. This is the second address. You can read it. Third address here. But it's as easy, just here. So if you look at packet 2, you should be able to see CNAME and 3 IP. Are you able to do so? There's no need to filter because, so that's the DNS. So you don't filter it. You just look at the second packet. Which is second packet? Which is packet 2. Okay. Can I use your mouse? Okay. So this is the second packet, yeah, packet 1, packet 2, this one. So if you see this, it's the standard query, DNS query, response. But what you are looking for? The server of this. So it will respond saying this is the CNAME. This is the server you are looking for. This is the CNAME. CNAME is www.one.google.com. This is the first IP address. If you keep scrolling, you see others as well. Oops, sorry, this one. That's the first IP address. That's the second one, and so also if I double click this, I can get to see. So this is the CNAME. See, this is the CNAME. If I click on this is the first IP, and the second IP, there's the third IP. Oops. This one. And where you are able to see this? Under DNS. Yeah, so this is a way to understand. So it's you can look at all the packets, for example, frames. You look at the bytes and so on, what's the frame size and so on. You look at Ethernet layer 2, what is the MAC address of source, MAC address. You can look at the IP address of source and destination on IP side. Use the datagram, checksum and so forth. And this is, because this supports DNS, there was a DNS query, so it says DNS response. If you look at the response, you get to see all this information. Are you able to see in packet 2 what the information I'm talking about? Yeah? Yeah, so that's what I'm saying. It's, if you look at this, so this is a DNS query response for google.com that you were looking for, and the CNAME is this one. CNAME is kind of a name of that server. Sometimes they alias it. And there are 3 IP addresses. This is the first IP address, this is the second IP address, and this is the third. So if you double click this, if I double click, I get to see. So all this should be within the DNS. So this is frame. You can look into what bytes and been sent to you. Ethernet, this is a layer 2 protocol. So if you want to know the MAC address of source and destination, you can get to see here. If you know the IP address, source and destination should be here. Internet layer, internet protocol version. UDP transport layer, if you want to know which port number being used and so on. And this is DNS. If you go down to DNS, or you can also read it here. So if I click here, let's say this is the query. I'm looking for www.google.com, and this is the response. That's the CNAME. See this one. CNAME is this. And if you check this, this is the first address. You see address. This is the first IP address. If you go there, this is the second IP address, and this is the third IP address. So everything within the DNS packet. That's how you can observe all the details. Are you guys able to see this? Yeah? In DNS, yeah? No, not frame. Go to DNS. Last one, yeah. Or you can read it from here as well. Click here, it will show it. So for example, if you're looking for, so this is the query we're looking for google.com. So this is the CNAME, a common name. This one says CNAME is this. First IP is this, second IP is this, third IP is this, the address. So those are 3 addresses being used by the server.
Address code.
These are bytes, sorry, hexadecimal, I guess. But if you go here in detail, you can read it. You can understand all those things. But your computer understands bytes, so everything is either in bytes or hexadecimal. How are you guys? Are you able to see this? Or do you want me to explain it? Okay. You guys can also, can I have one computer so you all can look? Okay, let's do this so you understand it, what I'm saying. So what we said is look at packet number 2. So can you open packet 2? Which?
So, right,
Okay, let me see it, then I'll. Which one?
this.
This is packet 2. Okay, yeah. So you click on this packet 2. Now what happened so far? Whenever you search something, you hit enter, what will happen? Very first thing, because you know the name, you say www.google.com, right? You don't know IP. But your system is trying to connect to the server, it needs to know the IP address. How it can know? Through DNS. The very first thing is, whatever name you are you have entered, it will look for IP address equivalent to that through DNS query. So it will connect to the DNS server, find out what are the IP address associated to this domain. And in second, you get a response with the answer. So packet 1 is DNS queries, packet 2 is DNS response, right? So what is happening in packet 2 so when you double click, you see frame 2, Ethernet, internet protocol, user data protocol, and so on. So frame is simply layer 1 or 2, kind of you see bytes and bits, how many bytes are being sent, what is the size of the packets, and so on. Ethernet is generally layer 2, you get to see what is the MAC address of source, MAC address of destination. Internet protocol, you got to see IP addresses of source. If you click on this, you get to see all those things here. User datagram or sometimes UDP or TCP depending upon, so you see port numbers and so on. But in this case, we are interested to look at DNS. So there's a DNS, this one, right? And you can read everything here. So this is the content, these are bytes, hexadecimal code equivalent to this. So if you, and in order to do so, you can directly click in and it will move it. So for example, if I click on this one, so you see the query is about www.google.com. That's what we wanted to know. And if you click on the other text that you have, maybe this one, you see this is the CNAME. I mean, if you look at this, you can get to see everything, but it's too long. I'm just clicking to get to know particular information. So that's the CNAME of the server. If you click on this one, this part, you got to see the address. That's the first address. If you click further, you got to see the other second address. If you click on the third one, you got to see. So again, there may be one address, there may be more than one address. It depends on how companies is supporting this. So for DNS, so that means they are having 3 IP addresses. I mean, they have 3 different servers that are supporting this email, searching thing. Yeah, so that's how you can get to see what is the CNAME, common name of this. Common name is kind of name of the server. Sometimes they rename alike. It could be different. Sometimes people don't want to put the exact name of company and server. They want to keep the server hidden for some purpose or with different names and so on. Yeah, so we are able to, so in packet 2, we are able to see 3 different types of IP addresses and CNAME. Yeah, are we done, everybody? Okay. Now what is happening in frame 345? Which protocol we are talking now? TCP. What's happening? Can I get to see, because I don't have on my system. Okay. It's fine. Okay. So 345 is about TCP. Now when TCP starts, what happens? Very first thing. If you need to use TCP, what do you do?
Connection establishment.
Yeah, handshake. Yeah, so it's a 3-way handshake. That's why you see 345. All protocols are TCP. And what they are doing? Connecting, sending request, getting acknowledgement, and then completing the loop. That's what you see in 3 packets. Right, TCP has their window size as well, so sometimes depend on the traffic, the window can be extended or can be reduced. So everything generally does, TCP does this automatically, user has no idea what's going on, right? But if you have a lot of traffic, they might increase the size, window size, so they connect. You can also decide on what should be the rate of packet you should be receiving, because you might not have enough bandwidth. Yeah, so you can say I can only accept 1,000 bytes in one packet, for example. So you set it, so everything will be delivered on that capacity in a way to control it. Again, we are not going to this, but then 345 is about TCP handshake. That's what we see in order to complete a connection. What is happening, what else? What is happening in frame 6 and 7? So what is 6? This one, yeah?
Yes.
So 6 is about HTTP, which says get HTTP 1.1. What is get?
Fetching the address from the respective
Right. So whatever query you sent earlier, now you start receiving response.
responses of
Right. You're ready to collect data. Now what is happening in some number 7?
acknowledgement for that.
It's a TCP protocol again, which is what it does. It's simply changing the, I guess, the window size. It's preparing yours to collect data. Yeah, so it's more or less control thing, control command or control rather than the actual data. And now it's a ignore frame 8. What is it? Again, it's a TCP update, things like that. Sometimes your client says, please extend your window size, change window size, and then you do it accordingly if this, to collect it. Sometimes file is too large, and so on. Okay, what is happening then? What else? What is happening in frame 9 and 10? How these two frames related? What is happening 9? What is 9? TCP, and 10 is about HTTP. So what is happening 9 and 10? What is TCP PDU resembled in 10? What does it mean? And you see this in a couple of times. What's happening there? So now your computer is ready to receive data, yeah, as a response to your query. But the data is too large to be delivered in one packet. So what it does, TCP does something called assembling and segmenting and desegmenting kind of thing. So it divide your packet, the whole data into packets, and send all the packets one after another. And that's what is happening here. Based on what is the maximum size TCP can support in terms of payload, packet size, it's a number of packets to deliver all the content. Yeah, and in number 10, what is this? HTTP 200, okay, which means we are done. We have responded it, and we have sent packet. Here it is. Seems to be everything is done. We have responded it successfully. So I got the answer of your query in a way, right? And then you have number 11. Say after the initial set of packets is received, the client sends. Oh, sorry, let me go there. Right. After the initial set of packet received, the client sends out a new request in packet 12. This occurs automatically without any action by the user. Why? What's happening in packet 12? What is packet 12?
In getting the response in the form of images or the
Right. So again, you see there's a GET HTTP, but as a user, you did not request anything. So what's going on here? Why this is happening? You just sent a query earlier, but not now. But you're still getting HTTP GET. Why? Because when you are retrieving a page, for example, that page might have text, it might have images, it might have audio, whatever, depending on what content you are asking to deliver. And in most of the time, these contents are physically at different locations. So generally, companies that we maintain, they put all the images at one place, all the text file in one place, audio, it's not, and the way it's displayed to you, because you have HTTP format or whatever. So when you receive all the data, it represented in that way. It follow that format. The image should be go here because you have that logic there. Yeah, but its job is to deliver everything. So when you're requesting a page, the server will look into all the text. Where's this text? Maybe in text file. It will fetch it, send it a packet. But might be the page also have images. But the images are not stored on those servers, somewhere else. So that server will automatically connect to that server, and the server will start delivering. So in this case, images. That's why you see this automatic GET for the images. Yeah. So you see HTTP GET image, which is logo.gif. Right, and then you see kind of other packets, the number of other packets coming to you from packet 13 to what? 13, 14, 18. Right? So that's what is happening. what is occurring in packets 13 to 22? That's what I said. So the whole mess is divided into packets, and you got all the packets one after another. Again, depending on it's keep changing its window size automatically. Right? What is happening in 23 to 26? What is favicon? We talk about this in one of the lecture. What is favicon? Yeah, that's the icon. That's the icon that you see in front of address bar. Yeah. So that might be somewhere else. So you get to see that get favicon.ico, and again it's sending packets, images, and then have HTTP 200 OK and so on. And 26 it deliver and acknowledge all those things. Then in one sentence describe what the user was doing. Reading email, accessing web page, FTP what? Accessing a web page, yeah? So if you are accessing a page, asking it to deliver something, this all happen. So these are 30, how many? 20? 26 packets. It takes to deliver 26 packets, running different protocols, just to fetch one page. If you're thinking everybody is doing so, having 10 pages every second, every minute, how busy the server and traffic it. There's so many protocols going around this. There's too much traffic in the network actually. Are we good? Everybody follow this? Okay. So this is all for today. Tomorrow we'll have another exercise where we will similar. We'll have some malicious content as well. So we'll see if we are able to detect and derive, able to answer some of the questions. Yeah. So if you go, so I'm just not go, but just I'm saying. So if you see this, maybe this one, yeah. Is this? No, this one. By default disabled. Is this your personal laptop?
Yes.
Yes, I think somebody already disabled. That's why you can't capture. But if you connect this to your own Wi-Fi, you should be able to capture. So you go to Azure, say somewhere, say run. You run it, start doing whatever you're doing. It will start capturing all the packets, like all the packets. This is what happened, and then you can analyze actually what a user was doing, and that's how you can catch people. Yeah. Right, so we will, any questions before we stop for today's session? It's just the one more day for you guys to bear me, and then we are done, yeah? If there are no more questions, then we are good to go. If you have questions, I'm happy to answer. Any other questions, not just this one, whatever we have gone through or any other thing. Okay, seems to be no question. Then thank you very much, and then see you guys tomorrow. Okay.